Okay, test 17 study guide. Roland averaged 5 jousts per journey on his first 7 journeys. So you just take a look at the way the average is written, 5 jousts per journey. It tells me that what goes on top of our averaging is the number of jousts. And on the bottom is number of journeys. If you just kind of get an idea, they don't always give us this type of unit, but in this case they're actually doing that. So kind of establishes what goes on top and bottom as far as things are concerned. It continues, it says he averaged 16 jousts per journey in his next 3 journeys. What was his average number of jousts per journey? So his overall average is what you're looking for. So we need the total sum. Alright, to get total sum we have to establish how many jousts he had in each situation. So 5 jousts per journey on 7 journeys. If we multiply this times this, it gets me 35 jousts. And if we take a look at the other scenario, he averaged 16 jousts per journey on his next 3 journeys. So 16 jousts per journey times 3 journeys is equal to 48 jousts. So we can see by the averages they gave us, we can figure out how many jousts he actually had. So if we add those up, we find out he had 83 jousts. And again, it's jousts per journey. So 83 jousts is the top number. All we need on the bottom is the total number of journeys. So if we take a look, first 7 journeys and next 3 journeys. So just looking at that, we can see very clearly there's only 10 journeys. So 83 jousts on top and 10 journeys on the bottom. And if we divide that, we end up with 8.3 jousts per journey. And you should expect Roland to be jousting on the test also. It'll be done similarly. Number 2, convert 20,000 cubic meters to cubic yards. So I'm going to go from meters to centimeters. Centimeters over to inches, inches over to yards. And the facts that we have is that 1 meter is equal to 100 centimeters. 1 inch is equal to 2.54 centimeters. And 1 yard is equal to 36 inches. Okay, and it does say cubic, which means there's 3 conversions required per unit change. So if we start off with 20,000 cubic meters, that's meters cubed. If I start off using this fact, we know that 1 meter on the bottom is equal to 100 centimeters on top. That's cubic meters, this is just meters, so I have to cube this, which cubes meters, cubes 1, cubes centimeters, cubes 100. But now meters cubed cancels meters cubed, and we're now into cubic centimeters. Next I'm going to use this fact, and I know that centimeters on bottom, inches on top. 2.54 centimeters is equal to 1 inch. This is cubic centimeters. This is only centimeters, so this needs to be cubic also. Now cubic centimeters, cancel, cancel. In addition, 2.54 inch and 1 all got cubed. And finally, our last fact, yards to inches. I'm going to put inches on the bottom, yards on top. 1 of these is equal to 36 of these. This is cubic inches. This is only inches, so this needs to be cubic inches. Cubic inches cancels cubic inches, cancel, cancel. In the process, yards is cubed, 1 is cubed, 36 is cubed. So altogether we get all that stuff. So to get the answer, I'm simply going to do 20,000 times 100 to the 3rd power divided by 2.54 to the 3rd power divided by 36 to the 3rd power. I'm going to type it in my calculator just like that. So 20,000 times 100 caret 3 divided by 2.54 caret 3 divided by 36 caret 3. And my calculator tells me it's 26,159.01 cubic yards. As far as reasonableness of results there, a meter is slightly larger than a yard, so the fact that this number is larger than that seems meters larger, so it would take more yards to make the same number of meters, so that seems to be reasonable as far as I can tell. Number 3, what fraction is asking for a fraction answer of 108 is 18. So what fraction of 108 is 18? So just direct translation of the words into an equation. Anytime you have fraction of, that means multiplication. Fractions being multiplied by 108, so divide both sides by 108 to get the 108. So 108 cancels 108, leaving the fraction that we don't know by itself. Over on the other side, we actually have a fraction. We should look to reduce if at all possible. Obviously, 2 goes into both numbers if you don't see anything else. 9 and 54 reduces to 1/6. 18, of course, would have gone into it to begin with. I would like the fraction reduced to the lowest term, so make sure you do that. If you're not sure how to reduce, you can always go to prime factorization. 18 is 2 times 3 times 3. 108 is, if we did 9 times 12 to begin with, it'd be 2 times 2 times 3, that's the 12, times 3 times 3, that's the 9. 12, 9. So if you get everything in prime factorization form, 2 cancels 2, 3 cancels 3, 3 cancels another 3. What we're left with on top is a 1, and on bottom 2 and 3 makes 6. So always reduce the lowest term when possible. Again, it does say what fraction. I do expect to have fraction answer on that one. Number 4, simplify, write the answer with all exponents positive. So what we have here is a main fraction bar here, and we have term 1, term 2, term 3, term 4. Every term on top and bottom is separated by pluses and minuses. Of course, the main fraction bar separates terms also. So we can identify our terms. The only fractions that exist in this problem are 3 over a and 2 over a. So those are the ones we have to worry about a common denominator for. The least common denominator of 3 over a and 2 over a is simply going to be a. So times a times a times a times a. Every single object gets multiplied by that a. Looking at all the terms, first term here, a is being multiplied by 7, that's simply 7a. Second term, it does say minus, make sure you write minus. I don't want to feel bad for the kids that did that in the past, but that's the most common mistake on this problem. If somebody throws a plus sign, we're supposed to be a minus sign. So be careful, signs don't get modified here. 3 over a times a, the a's cancel, so I just get minus 3. Next term here, we have 2 over a times a, the a's cancel, leaving 2, and that does say plus. So make sure you put a plus sign, and then c times a is just ac, and that's the end result. Okay, and that's all that should happen on that problem when the test comes about. So expect the same type of issue, fix it the same way, you'll be in good shape. Number 5, this is exactly the same kind of problem the last one was, just it's kind of in disguise. So we have x to the negative 4th, we have y to the negative 3rd, and we have x to the negative 2nd. The x to the negative 4th and y to the negative 3rd are being added together, so the typical idea where you move things up and down isn't legal on this problem. What I need to do is I need to fix each of these things in its location. So I'm going to create the same structure, something plus something over something, something plus something over something. And then within each location, this top left location up on the top here is 1 over x to the 4th. This is 1 over y cubed. And on the bottom we have 1 over x squared. Fix that y so it looks a little prettier. Right. Once you get it to the real life way it looks, then we simply fix each one the same way. So term 1, term 2, term 3. I need to find the least common denominator for these 3 terms, which I can see is we have x's, the highest power of x is 4, and we have a y, the highest power is 3. So x to the 4th y cubed is going to be what we multiply by. So our end result, again, creating the exact same structure, something plus something over something. We just need to fix the somethings. Each thing we're multiplying by is a numerator object being multiplied by something with a denominator. So x to the 4th and x to the 4th cancel. 1 times y cubed is just y cubed. Y cubed cancels y cubed. 1 times x to the 4th is just x to the 4th. Down here on the bottom, x squared goes into x to the 4th, not completely though. There's still an x squared left. So 1 times x squared y cubed is x squared y cubed. Do not try to reduce the fraction. That's as far as you can go on that problem. Stop there. Number 6, simplify 6 square root of 27 minus 2 square root of 12. I'm going to take each of these individually. And once again, it is a minus sign there, so make sure you account for that. What I want to do first is I want to factor the numbers here. So 27 is 3 times 3 times 3. I'm going to put minus, I'm going to leave a little space here, 2 square root, and 12 is 2 times 2 times 3. Depending on your abilities with factoring numbers, if you're really good at it, you might be able to do it just like that. If not, if you're not 100% certain on how to factor, let's say 27. 27 is 3 times 9, 3 is prime, 9 isn't. Once you get everything factored down to all primes, you stick it in there. 12 is the same way. 12 is 4 times 3, 3 is already prime, 4 isn't. Once you get all primes, then you stick them in there. So again, factor it as down to all prime numbers. Do not leave any composite numbers, only primes. I personally like numerical order when I write them, but it's not that important. So for this one, anytime you have a pair of primes, you get to pull one out. So a pair of 3s makes 1 3 come out. And anything that gets pulled out is going to be multiplied by what's in front. Same deal here, we have a pair of 2s. We get to pull a 2 out, it is multiplied by what's in front. So my end result for the red circled object, simplified as much as possible. 3 times 6 is 18 times the square root of 3. The end result for the green circled object, simplified as much as I can, minus 4 times the square root of 3. And that's the end of it as long as these are different radicals. But if they're the same radical, like in the case we have here, we then have to add or subtract the coefficients. So 18 minus 4 makes positive 14. And a square root of 3 next to it to account for the fact they both share the square root of 3 radical. I would expect the problem on the test to do the same thing. So once you've simplified these, the radicals should be the same. Add or subtract based on sign. So positive, negative, opposite, subtract. 18 is bigger, so it's positive. The square root of 3 will make them the same. That attaches to the answer. Number 7. First thing I would do on a problem like this would be to fix each mixed number, make it into an improper fraction. So the x is officially in the numerator. So 25 times 4 is 100 plus 1 is 101. I personally just put the x up on top so there's no doubt that's where it belongs. Second object is plus 6.5, still plus. 6 times 2 is 12 plus 1 is 13 over 2. And that equals 3 and 1 16. 3 times 16 is 48 plus 1 is 49 over 16. Once I've made everything an improper fraction, next thing I would do is I would multiply by the least common denominator of those fractions, 4, 2, and 16. Least common denominator is 16. I'm going to multiply 16 times each object, get whatever product I get. So 16 divided by 4 is 4, times 101 is 404x. 16 divided by 13 is 8, times 13 is 104. And 16 divided by 16 is 1, times 49 is 49. So just like that, we've gone from mixed number to improper fraction to all integers. Once you get down to all integers, the easiest equation you can possibly make, then it's just a matter of solving that equation. I would move the 104 over here. 404x is equal to negative 55. Divide both sides by 404. Again, considering the possibility, can I reduce this fraction? If you take the smaller number, reduce it to prime numbers, 5 and 11, you simply have to see if either one of those prime numbers divides into the bigger number. So 404 divided by 11 does not divide evenly, and obviously doesn't divide by 5 because it doesn't end in 0 or 5. So it's not reducible, so that is the best answer. Always reduce fractions to lowest terms. Number 8. 8, 9, and 10 are all this kind of problem. I'm going to prefer elimination over substitution in each case. That's the newest technique we've learned. The goal of elimination is to get rid of a variable. It doesn't matter which one you get rid of. Sometimes one's easier than the other to get rid of. In this case, the fact that this is 3y and this is also exactly 3y, they're exactly the same thing, makes getting rid of y very simple. It is required that they have different signs though, so they're both positive, that's an issue. The first thing I would do is change all the signs in one of the equations, doesn't matter which one. I'm going to take this one. I'm going to make each object opposite. So 5x becomes negative 5x. 3y becomes negative 3y. 27 becomes negative 27. Make sure every single sign changes. If you're going to change one, you change all. And now I'm going to deal with these two equations instead of those two originals. And at this point, add together all like terms, either add or subtract based on signs. In this case, these signs are different, so I subtract. 7 is bigger, so it's positive. 3y minus 3y cancels, eliminating the y variable I wanted to get rid of. 33 minus 27 equals 6. Again, subtraction because the signs are different. Positive because 33 is bigger. Divide both sides by 2, and just like that we know that x equals 3. Once I know what x equals, I go back to either equation, doesn't matter which one. I like the very top one. It says 5x plus 3y is equal to 27. I know x, I do not know y. X equals 3, so I put a 3 right there. 15 plus 3y is equal to 27. We move the 15 across, change the sign. It gets me 3y is equal to 12. Subtraction because the signs are different. Positive because 12 is 27 is bigger. Divide both sides by 3, we get y is equal to 4. And just like that, 3 comma 4 is the correct answer. X goes first, y goes first in the ordered pair, or y goes second in the ordered pair. Example 9, or number 9, is the same kind of problem. This time, these aren't the same, neither of those. We don't have different signs on anything, so getting rid of either x or y, one's just as good as the other. I'm going to get rid of y again. So I'm looking at these two y terms. I want them to be the same but opposite. I'm thinking the number 6. 2 times 3 is 6. 3 times 2 is 6. One of those 6's has to be positive. So I'm going to have to multiply one of these by a negative to make that happen. So I'm going to take the top equation times a positive 3. I'm going to take the bottom equation times a negative 2. Okay, so just looking at the y issue here, 3 times negative 2y is negative 6y. Negative 2 and negative 3y is positive 6y. So that opposite sign term is going to happen there. And if I just multiply 3 through the top, I'm going to get 15x minus 6y is equal to 3. Multiply negative 2 through the bottom. Negative 2 times 7x is negative 14x. Negative 2 and negative 3y is positive 6y. And negative 2 and 1 is negative 2. If I add the equations together now, 15 minus 14x makes 1x. Different signs subtract. 15 is bigger, so it's positive. Negative 6y, positive 6y, opposites cancel completely. 3 minus 2 is 1. Opposite signs subtract. 3 is bigger, so it's positive. Just like that, x equals 1 is the correct answer for x. Going on to find out what y is, I know that 5 times x minus 2y is equal to 1. Again, I just established the value of x, it goes right there. We with that same equation, just changing x to what it equals, leaving y as a variable. 5 times 1 is 5. If I move the 5 to the other side, subtract, I'm going to get negative 2y left on the left-hand side. 1 minus 5 is negative 4. Different signs subtract. 5 is bigger, so it's negative. We divide both sides by negative 2, we're going to get y is equal to positive 2. So here's the division. 2 negatives make a positive, 4 over 2 is 2. Once again, my ordered pair, x goes first, y goes second in the ordered pair. Always write your answer as an ordered pair for this type of problem. Finally, number 10, I've got x plus 2y equals 17, 3x minus y equals 9. Once again, I'm just looking at the y's here. Plus 2y minus y, that's real simple. If I take the bottom equation times 2, negative 2y, positive 2y will cancel. So I'm going to leave the top equation as is. I'm going to rewrite it just so I have it closer to the one I'm going to be working with. So there's x plus 2y equals 17, as is. Doubling everything in the bottom equation, 2 times 3x is 6x. 2 times negative y is negative 2y. 2 times 9 is positive 18. Just like that, here's my new system of equations. And positive 2y, negative 2y are going to cancel. So adding the equations together, 1x and 6x are both positive. Add makes 7x. 2y minus 2y cancels. 17 and 18 are both positive. They add, and positive 35 is the result. We divide both sides by 7. It ends up getting me x is equal to 5. Wants to know what x equals. I go back to one of the equations. I think the top equation looks friendlier. So I'm going to take this top equation. X plus 2y is supposed to equal 17. Once again, x is known. So that's just 5 plus 2y equals 17. Move 5 over and change the sign. That's going to equal 2y is equal to 12. Divide both sides by 2, y is equal to 6. X first, y second. So expect those problems all to come out to nice integer answers like that. If they come out in fractions, you probably did something wrong. Most common mistake is multiplying this times these two, but forgetting to multiply by that kind of thing. So just be watchful that you follow through the steps carefully. And do not abandon variables. Make sure this says x equals 5. Don't just put 5. Make sure x equals is there, so you're establishing what's what. You're putting x in here, not y, and so on. So just be watchful in your work. Make sure you go through your work properly. Number 11, graph y equals negative x plus 1. It's already y equals form. The way we've been doing this so far is we just pick some x values. Anything you want to pick. There's no fraction, so anything you pick will be fine. If there were fractions, you might be a little more watchful that you pick multiples of the denominator. Change the sign of x, then add 1. Negative 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 2 plus 1 is negative 1. Then just pop the points. So 0, 1 goes here. 1, 0 goes there. 2, negative 1 goes there. If you're iffy on the zeros, some people go the wrong direction on the 0 points. Just don't pick 0 points. Like pick, obviously you might pick 1, but then you get 0, just throw that one out. Pick 2, 3, 4. Change the sign, add 1. Negative 3 plus 1, negative 2. Negative 4 plus 1, negative 3. So 3, negative 2, 4, negative 3. But they continue on the same line. So if you're iffy on the 0, 1 or 1, 0, which direction you're supposed to go, you can handle it that way. So connect the dots with a nice straight line, like so, and get your answer. Number 12. This says add. Doesn't say add like terms, so that implies get a common denominator and get it into a single fraction. And it doesn't look like fractions to begin with, but notice that we have negative powers, so 4ab to the negative first power. 4 and a are on top, b to the negative first, but b on the bottom. Minus ab to the negative second, so minus a is on top, b is on the bottom. And sometimes people see minus signs and they see negative powers, they start thinking they're the same thing. A is to the first power, so that's why it's on top. B is to the negative second power, that's why it moves down. A minus sign in front of that just puts a minus on the 1 that's in front of the A. It's not moving anything. And then we have plus 4, which is just plus 4. Officially over 1. Looking at the denominators b squared, and 1. The only thing that isn't 1 that goes in the denominators is b. The highest power is b squared, so I want every denominator to be b squared. Alright, so if we take a look at each of our objects, so starting off with 4a over b. 4a is what we had on top. We have to ask ourselves, what did I multiply to get b squared? So for this one, times b, so times b is going to be the change there. Okay, so whatever makes the bottom what we want it to be, is what we need to multiply the top by. Second fraction, minus 1a times, all right? If we take a look at this one, b squared, they're the same. So officially times 1 if you really want to put anything there. You don't have to. It's already got the right denominator. Don't worry about it. And then the final one, we're going to have plus 4 times something. 1 became b squared. That requires multiplication by b squared, so times b squared on top. So in each case, each fraction is whatever it was. You want every denominator to be b squared. What does it take to make that happen? Do the top also. End result. Common denominator goes in the bottom. Simplify each of these as much as possible. This is just 4ab. That's going to be minus a. That's going to be plus 4b squared. That's as much as you can possibly do to that problem. Don't try and reduce it. Stop there. The only reduction possible might be a b. B, no b. So the fact this term is missing a b means reduction by b is impossible. So least common denominator, make every denominator the least common denominator. Modifying the numerators appropriately, and then just simplify everything. 13, I believe 14 also, are just laws of exponents. they kind of look different, but they're basically the same kind of problem. I just want to highlight something that I don't think I've made a good enough point about. We're multiplying these two things together, and the green object is all this stuff in parentheses to that power, the blue is all this stuff in parentheses to that power. The point I want to make here is that when you're fixing the powers, you can make just one big fraction out of the whole problem right now. You don't have to keep them separate at this point. This x belongs on top. Negative 3 times negative 3 is 9. This y belongs on the bottom. Negative 5 and negative 3 make positive 15. Put them where they belong, move them in the next step if they were negative powers still. The blue object, y belongs on top because it's on top, 2 times 2 is 4. X belongs on bottom because it's on bottom, 3 times 2 is 6. And the point I'm making here about this is, notice they're not two separate fractions anymore, I stuck them into one fraction. Top stuff on top, bottom stuff on bottom. Each fraction is part of the problem. They're all getting put together anyway, so you can immediately put them into the same fraction in that step. Step 2 is to deal with any negative powers that might still be there. The reason we do this step first is because a lot of times multiplication gets rid of negative powers, which it did here. All the negative powers have disappeared, so we're ready to go with that. The very next step, if the same letter happens on top or bottom, we deal with that. That's not happening here, so we can skip that. Final step is we got to put x where it belongs, y where it belongs, based on powers. X on top, x on bottom, higher power on top. 9 minus 6 is 3. Y on top and bottom, bigger on bottom, that's where it belongs. 15 minus 4 is 11. That's the answer to that problem. So only 2 steps actually happen, but I did go through each step individually, make sure that I've looked for those situations. So power to power did it. No negative powers, checked off, move on. The same letter doesn't happen on top and or bottom individually, so move on. The same letter on top and bottom, so we got to then do the subtraction of powers to account for the division. Same deal here. First thing I'm going to focus on is this and this. So the x to the second, y to the negative third is being left alone. If I deal with all the stuff, power to power situations, just base stays the same, 0 times 3 is 0. Base stays the same, 2 times negative 2 is negative 4. Base stays the same, 2 times negative 2 is negative 4. Base stays the same, 2 times negative 2 is negative 4. Every inside power times the outside power, the bases stay the same. Step 2, now I do see negative powers, so I'm going to deal with the negative powers and the 0 powers. So all 5 of these guys need to be dealt with. So x squared is behaving itself, it gets to stay right where it's at. This x to the 4th, y to the 4th, and p to the 4th all belong on the top. This y cubed belongs on the bottom, and this p to the 0 is just equal to 1 times 1 doesn't do anything. So now all the negative and 0 powers are gone. Now we're left with, hey, there's too many x's on top. So we're going to move on to that. So, too many x's on top. Everything else is fine. There's 1y, 1p on top, 1y on bottom. Everything's behaving itself there. X is going to change. Y to the 4th, p to the 4th, y cubed are going to stay right where they're at. Those are the same. This x, 2 plus 4 makes 6. When you're multiplying letters, you add powers. And finally, we have too many y's. So x to the 6th is behaving itself, p to the 4th is behaving itself. They're both in the numerator. Y belongs in the numerator also. 4 minus 3 is 1. That's a optional power. If you want to write it, fine. If you don't want to write it, fine. That's the right answer. That's also the right answer. I personally would write it that way. And again, everything ended up on top. So you can put over 1 if you felt like it. Not a requirement. If you write it as a non-fraction, it's understood that everything's in the numerator. Okay, final problem. Probably the easiest problem on the test. It comes from like lesson 4, I think. But it's also one that's frequently missed by students because they start overthinking things. First off, this is 8. This is a rectangle, so this is also 8 up here. So these two dimensions are equal. Also, they don't tell us the length of this piece here, but if I were to sketch in a diameter here, 3 up and 3 down is a total of 6, so this is also 6. Okay, those parts don't tend to be very difficult for people. The part that messes people up is the fact that this semicircle goes inside. Right? Now, the length of a semicircle, half a circle, is just pi times the radius. So So the radius is 3, so 3 pi is the length of that. Okay, I've used the radius to find the length of this. I'm not going to add the radius to the perimeter. All right, 3 times pi is about 9.42. So if we look at our 4 sides to this figure, and we're trying to find the perimeter of this figure, this and this and this and this all add to the length around this figure. So a lot of people see this thing going inside, they think I got to subtract because it's going inside, but imagine walking around this figure. 8 adds to my walk, 6 adds to my walk, 8 adds to my walk, 9.42 adds to my walk. Everything's adding to my walk, so I need to add all those things up. So 8 plus 6 plus 8 plus 9.42, and then it's just a matter of adding them up. The decimal kind of just going to be 0.42, and then we just have to add the whole number parts. 8 and 6 is 14, and 8 is 22, and 9 is 31. Dimension is centimeters. 31.42 centimeters is the perimeter of that. So find the length of each of the 4 sides, one of those sides of course being a half circle, pi times the radius, and then add the 4 sides up and you get the perimeter.